Okay, in this video we're going to do some odd problems. This is for section 6-2, the disk and the washer method. You've got the homework assignment, and here in this video we're just going to do a couple of the odd problems adjacent to those evens that you have for homework. The first one we're going to look at here is number 1, and the directions in the book say to set up and evaluate the integral that gives the volume of the solid formed by revolving the region about the x-axis. So here, if we look at the graph they provide, we have this downward sloped line. I did that in green. That's our y equals negative x plus 1. And our rotational axis here is the x-axis, so I'll put my rotational arrow on there. And we want to find the area of this region. You know, if we rotate that about the x-axis, what will be the volume of that rotational solid. So I did draw in the representative rectangle. Notice that the top of the rectangle is touching our curve, or in this case it's a straight line. The bottom of our representative rectangle is touching our rotational axis. So when we spin this around, you know, the outer edge will be here, but the inner edge is touching our rotational axis. So this is going to be the disk method. It's not going to be the washer. We're not going to have a hole in the middle of our rotational solid. So let's see here. We're going to do volume equals, and we'll have pi. And then our integral symbol. Because we are perpendicular to the x-axis, we will get our lower and upper limits from the x-axis. So we're going to start here at x is 0 and move along here until x is 1. When we're here, our representative rectangle will be 1 unit tall. And then as we get out here to x is 1, we will be 0 units tall. So let's see here. Oops, so we're going to go from 0 to 1 on the x-axis. In here, this is going to be our representative rectangle, its height, and then that'll be our axis, or that we will quantity square it. So what goes in here is our function, our negative x plus 1. And we'll give that a dx because we're doing everything here in respect to the x-axis. So here again, this is just the height of our representative rectangle. What determines the height of this rectangle is our function. At x is 0, negative 0 plus 1 is 1. That's the height of our rectangle. If we put x is 1 in there, negative 1 plus 1 is 0. That's the height of our rectangle at the other end of this area. So from here on out, let's see, we're going to still do a little algebra next before we do some calculus. We are going to have to FOIL this out. When we FOIL, that will be a positive x squared minus 2x plus 1 dx. And now we're ready to anti-derive. So that'll be x cubed over 3 minus 2x squared over 2, or just an x squared, plus 1x. We will evaluate that with the fundamental theorem from 0 to 1. And remember, we got a pi out here as a constant multiple. Okay, time for the fundamental woo, get over there. Fundamental theorem of calculus. We got pi. I'll save that for the very, very end. But the 1 jumps in. So we're going to have a 1/3 minus 1 squared plus 1. And now just for completeness sake, you know, this was our upper limit evaluated. We're going to minus our lower limit in there, which in this case it's nice and easy. The 0 jumps in for all the x's, so that'll be 0 divided by 3 minus 0 squared plus 0. So that's just a big old wash there. And this negative 1 plus 1 is also going to wash out to a 0. So what we're left with is 1/3 times pi, which we can write as 1/3 pi, or pi divided by 3. So that was number 1. I think you have to do number 2 in the homework, so that might help with number 2. Let's also check out number 3. This is a red problem, so if you're sick of listening to me, you can always tune into Calc View and see if who's doing the video for this problem on there. So let's see what we're looking at now. We are again rotating around the x-axis. Our function is the root of x, and we're not starting from the origin because our square root function would look like this. We are just going from 1 to 4. So 1 comma 1, 2, 4 comma 2. Okay, once again, we are touching our axis of rotation. So this will not be the washer method. This is going to be the disk method. So let's see here. We're going to have pi integrated from. Again, we are perpendicular to the x-axis, so our limits will also come from that same axis, 1 to 4. 1 to 4. In here goes our radius, which is the height of our representative rectangle, and that radius will be squared. In this case, we are with respect to the x-axis, so I'll give it a dx on there. This is a nice easy one. Remember, in here is what determines the height of our rectangle, and here the height of our rectangle is what's touching the top of it is our root of x function minus what's touching the bottom of it, that is just the height of 0. Root of x minus 0 is just root of x. And this problem is just going to get nice and easy here because the square root and the square will cancel, leaving just an x dx. That's a nice easy antiderivative. Raise the power by 1, divide by the new power, and we'll evaluate that from 1 to 4. So let's see. Again, I like to save my pi for the very end. The 4 jumps in. 4 squared is 16. 16 over 2. Minus the 1 jumps in, the lower limit. 1 squared is 1. 1 over 2. 16 halves minus 1 halves is 15 halves. So 15 pi over 2 would be our final answer. 5, we'll skip that one. Number 7. Now this is where we're going to get a little more juicy with these. Let's see, I'm flipping through my notes for this one. In exercises 7 to 10, set up and evaluate the integral that is given, gives the volume of the solid formed by a revolution about the y-axis. Okay, this isn't the one I was thinking of that has 4 parts to it. So now we're going to the y-axis. So let's see here. So we're rotating around the y-axis. Our representative rectangle touches the curve and also our axis of rotation. So this is, again, going to be a disk method, not a washer method with the hole in it. Now here, because we are going to the y-axis, we're going to need to get our limits from the y-axis. Our volume is going to equal pi. And we can see here from 0 to 4. 0 to 4. And this will be dy. Because we are perpendicular to the y-axis, our limits come from that. Everything has to be in terms of the y-axis. So we're not going to put in there an x squared because the limits come from y and this is a dy. We want to solve this for the other variable. So take the square root of both sides. X equals the root of y. Remember, technically there would be a plus or minus on there, but since we are here in the first quadrant, we're only worried with the positive root of y. The negative root of y would be on the other side. So in here goes a positive square root of y. And remember, this is we're pi r squaring this plane region to get a rotational volume. So this is our radius squared. Ooh, so I like where this one is going. So we got pi. We will evaluate that eventually from 0 to 4. The square and the square root cancel just like the last one. So that's just a y dy. And we antiderive. Raise the power by 1, divide by the new power. We've got a constant multiple of pi out front. So upper limit jumps in. 4 squared is 16. 16 over 2 is 8. That'll be 8 pi. And when we evaluate the 0, we just get a 0 in there. So 8 pi would be our volume. Remember, this would be in some type of cubic units. Units cubed. Because we took a flat plane region that would be square units and rotated it around, creating cubic units. All right, number 13. Here's where it might get a little juicier. Okay. Okay, let's see here. Our problem is y equals the root of x. I've drawn that in here in the red ink. That's our curve. We're going to go from y is 0, so that is going to be our x-axis. That's one of our edges of our plane region. And then x is 3. So here is the region that we're looking at. We're going to be rotating this around some different things. But this is the defined region by these three components here. The root of x, y is 0, x is 3. Let me switch over to blue ink. For part A, we're going to rotate that around the x-axis. So I'm going to go here in blue. Part A is an x-axis rotation. So if I draw the representative rectangle, let me switch to green ink. Here would be the representative rectangle perpendicular to the x-axis. So for part A, we're touching our axis of rotation. That's going to be a disk method. For part B, we're going to spin it around the y-axis. So for part B, it's a y-axis rotation. I'll just stick with the blue ink here. So if we're going to rotate that around the y-axis, let's see here, we're not touching our axis of rotation until we get to the very end at the origin, but that's just for 1 second. So here it looks like it's going to be washer method. We have our outer radius, what's touching the outer edge of this representative rectangle, and then minus the inner radius here. Remember, that'll be outer radius squared minus inner radius squared. So for part B, it looks like we're going to have a washer method. Part C, rotational axis is x is 3. So for part C, we're going to rotate it around here. Now again, we're going to be using the same blue representative rectangle because we are perpendicular to the y-axis. So here we are again, we're touching our axis of rotation. So this is going to be a disk method, you know, the height of our rectangle, quantity squared. Part D, we're going to go out to x is 6. So here's the line x is 6. For part D, this is going to be our rotational axis. Again, here we're nowhere near our axis of rotation, so part D is going to be a washer method. So I'm going to leave this graph up here on this slide, just start making new slides as we start going through some of these. You're going to see some of these methods are pretty simple. Other ones are going to be a little trickier. It all comes down to these representative rectangles and the method that we need to find this volume of the solid. So let's see here for part A. I'll start a new slide. We're going to rotate about the x-axis. So let me just do this here. We're going to rotate around the x-axis. So this one shouldn't be a bad one to set up. Our volume is going to equal, we're going to have pi. Since we're perpendicular to the x-axis, our limits will come to that. That is our 0 to 3. And then here this is the disk method, so we're going to have some radius squared. This radius is the height of our representative rectangle. What's touching the top of our rectangle is the root of x, minus what's touching the bottom of the rectangle, just a 0. So that'll just be a root of x quantity squared. We saw something like this in the last couple odd problems we did. The square and the square root will cancel, just leaving an x dx. We anti-derive to x squared over 2 from 0 to 3. So upper limit jumps in, 3 squared is 9, that'll be 9 halves, minus the 0 jumps in 0 halves, and then we got our pi out front. So 9 halves minus 0 halves is just 9 halves, or 9 halves pi, 9 pi over 2. So part A wasn't bad. Again, just to recap, that was a disk method to the x-axis. Part B. Part B is now y-axis. Okay, so here it might be a little trickier. Let me do this. Our volume is going to equal pi integrated, and then we're going to do outer radius minus inner radius squared, and this is to the y-axis. So everything's going to be in terms of y. Let me draw a little picture here real quick. So here is our plane region to 3, and we're going to rotate it around the y-axis. So we're going to need an r of y, capital R of y, that's our outer radius, minus lowercase r of y, that is our inner radius. So we've got the pi. from. Ooh, now let's back up here a minute. We're going to need everything in terms of y. So this equation, I would have to square both sides. X equals y squared. So if y equals root x, x equals y squared, because we need our function to be in terms of y. And on the y-axis here, what would our limits be? So we're going on the y-axis, so 0, the root of 0 is 0, and then if we put the x is 3 into the root function, that would be a root of 3. So on the y-axis, we're going from 0 to a root of 3. Now we need the outer radius, which will go in here, and we're going to square it. And our representative rectangle looks like this. As it moves through the plane region, it is always going to be touching this side at 3. So our outer radius is just 3 minus inner radius quantity squared. What is always touching here, the edge of this, the other side of our representative rectangle. Remember, outer radius minus inner radius. Inner radius here is our function, and that we solved here for x equals y squared. So that's just y squared quantity squared. So before the calculus comes, we're going to do a little algebra. 3 squared, that's a 9, minus y squared quantity squared is y to the 4th dy. Okay, so this method isn't too bad. The anti-deriving and evaluating won't be overly difficult. So we're all ready to go. Antiderivative of 9 with respect to y is 9y. Minus, here we're going to raise the power by 1, divide by the new power from 0 to root 3. All right, time to evaluate. So the root 3 is going to jump in. 9 times root 3, we'll just leave that as a 9 root 3, minus root 3 to the 5th power. Root 3 to the 5th. So we're going to square it twice and then have an extra leftover root 3. So when we square it once, we're going to get a 3. Square it again, we'll get another 3. 3 times 3 is 9. And then we got a leftover root 3, which is just going to stay a root 3, and that's over the denominator 5. 9 root 3 over 5. Just for completion, if we do evaluate the lower limit, we're going to get 0 minus 0, so that just goes away. And let's get this as one fraction, then we'll put the pi in at the end. Let's get a common denominator here of 5. So multiply top and the bottom by 5. We're going to get 45 root 3 over 5 minus 9 root 3 over 5. Now with the common denominator, that will be 36. 36 root 3, and let's put the pi in there now. So we're going to subtract there, get our 36, put the pi in there with the root of 3, all over 5. Nice. Okay, letter C. Let's flip back to our original slide and graph. Part C is x is 3, so now we're back to the disk method. So it's just going to be a radius squared, and here we're touching it, so it's just disk method, not washer, but we still are with respect to the y-axis. So for part C here, we are still going to be everything in terms of y. So again, just a quick sketch here. Looks sort of like this. Our representative rectangle here, rotational axis. Again, we saw this in the last part. We are going to go from 0 to the root of 3 on our axis of integration. So our volume is going to equal pi. We will integrate from 0 to root 3. And remember, for the disk method, it's just some radius squared. Because, you know, our radius is the height or length of this representative rectangle. And then we're just going to spin it around that axis of rotation. So we need a little equation here that's going to give us the height of this rectangle. And this, in this case, I think, in my opinion, is the trickiest part. When we put in y is 0, we need a rectangle that is length 3. When we put in a y value of root 3, we should get a rectangle length of 0. So let's see here. We just got to sort of think this through a little bit. Um, 3 minus, remember when we solved this, this was y equals root of x. So if we square both sides, x equals y squared. So 3 minus that. 3 minus y squared. I always like to do a little check on my ends at least. If we do put in 0, 3 minus 0 squared is 3, and that is the length of our rectangle. When we put in a root 3, 3 minus root of 3 squared would be 3 minus 3, or 0. We've got no rectangle left. So that's it. 3 minus y squared gives us our length of our rectangle, or in this case, that's our radius that we will rotate around our axis. Okay, hard part's done. Little algebra here. We're going to FOIL this out. That'll be a 9 minus 6y squared plus y to the 4th dy. We can now anti-derive. With respect to y, that'll be 9y. Minus, raise the power by 1 to 3, or raise the power by 1 up to 3, divide by the new power 3. 6 divided by 3 is 2. 2y cubes plus y to the 5th over 5 from 0 to the root of 3. So keep the pi till the end. Root 3 jumps in. So this will be a 9 root 3 minus 2 times, see, when I put a root 3 in there, I'm going to have root 3 cubed. But root 3 cubed is a root of 3 squared times another root of 3. So here the square and the square root cancel, so that'll be a 3 root 3 times this 2 will make that a 6. 6 root 3 here. Oops. 6 root 3 here. Plus, and we sort of saw this in an earlier part, a root of 3 to the 5th power. Well, we're going to have a couple of squares. One of the squares will be a 3. Another square is going to be a 3. And then we'll have a leftover root of 3. So that becomes a 9 root of 3 over 5. And when we do the 0, all zeros would 0 those out. Let's get a common denominator of denominator 5. So if we multiply by 5, that'll be a 45 root 3 over 5 minus 30 root 3 over 5. So this will give us a 15 roots of 3 over 5 plus 9 more roots of 3 over 5. That'll be what? 24. We're going to have 24 roots of 3 over 5. And then let's put the pi in there. 24 pi root of 3 over 5. One more to go. And this is when we move our rotational axis way over here to x is 6. So this is going to be a washer method. Washer method, and we are not touching our axis of rotation. Now this one will get tricky. The easy part to see here, here's our rotational axis, and here is what is touching the bottom of our rectangle. And that's true all the way across. So here our inner radius, our, in this case, lowercase r of y, is just going to be 3. So let me start to set this up, I guess. Here we're going to, let's do volume equals pi. We're going to have our outer radius, our capital R of y, that's quantity squared, minus our inner radius, lowercase r of y, also quantity squared, and dy, since everything here is with respect to y. So we've got the pi. We know from the last couple parts our limits of integration are going to be from a 0 to root of 3. And then here we're going to have our outer radius, quantity squared, minus our inner radius, quantity squared, with respect to y. And we already figured out here again, this, our inner radius, is just going to be a constant 3, because that is always what's touching the bottom of that rectangle. So this is just going to be a 3. Now, here is going to be, we need in this component, or in this set of parentheses, a little equation that's going to give us the height of our representative rectangle. Or I guess another way to say this, our outer radius is what's touching here as far our furthest distance away from the axis of rotation. So I guess we could approach it this way. Here is the farthest we will ever be away from our axis of rotation. Our axis is here at 6. The farthest we're ever going to be away is the origin. So that's the farthest we're ever going to go, 6, and then we're going to subtract stuff as we move along that y-axis. Earlier we did solve this. Y equals the root of x for the opposite variable. So that was x equals y squared. Let's just try to put that y squared in there and see what happens. Okay, so if we are here at y is 0, if we put 0 in, 6 minus 0 squared is 6. That is how far away we are from our axis of rotation. Up here, just below 2, is that root of 3. If I put the root of 3 in for this y, 6 minus the root of 3, that's squared. That'll be 6 minus 3. So there we are 3 units away from our axis of rotation. So that looks like it. We have a 6 minus y squared as our outer radius. 6 minus y squared. Okay, there, in my opinion, the hard part is over. Let's do a little algebra before we can get to the calc. So we have to FOIL this out. 36 minus 12y squared plus a y to the 4th. And then we're going to have minus 3 squared is 9 dy. So we can just combine, I guess, the 36 and the minus 9. And I'm going to put my polynomial in descending order. So let's put that y to the 4th first. Minus 12y squared. And then a plus 27 when we combine the constants. And that's with respect to y. Time for some calculus. Let's antiderive that. Y to the 5th over 5 minus 4y cubed. We'll raise that up to a 3, divide it in the 12 and get a 4 there, and then a plus 27y. We will evaluate that from 0 to root 3. Okay, work from other problems will come back to help us here. So the root 3 jumps in there to the 5th. That's 9 root 3 over 5. Minus, we're going to have root of 3 cubed, so we'll bring one of those out. 4 times 3 is 12. 12 roots of 3. Plus, this just becomes 27 root 3. If we get a common denominator, all those denominator 5. I'll just jump to the punchline here. Final answer, 84 pi root 3 all over 5. I hope these odd problems help with the homework. I think if you want to check out 17 there, I'm getting a little tired here. 17 is another odd problem. We're rotating that around y is 4. So that might, you could watch that on Calc View. Might be helpful there. Well, let me say, I might want to help out. There is the one on WebAssign. Maybe we'll just do a little scratch work sort of to set it up. If I can find it in my notes. Yeah. This is on WebAssign. This is also in your book. It's number 14. And if you look at the one in the book, the function is y equals 2x squared. Y equals 0, x equals 2. I believe in WebAssign, the things that vary are this x value and this coefficient. But no matter what you get there for your numbers, you're going to have, at first, some type of parabola. Y equals 2x squared. That would just be a steeply going up parabola. And if we're going out here to x is 2, if I put that 2 in here, 2 squared is 4, times that 2 is 8. They would have an intersection point here at 8. and the line y equals 0. So here's the plane region, this region in here. And let's see, for part A, let me switch over to blue ink. Part A, it's a rotational axis around y. Part B is rotational around x. Part C is this line up here. On mine, it's around this line 8, depending on what you get for your coefficients on WebAssign. And part D is around this. Part D, that is our rotational axis. So just real quick here for part A. Part A is around the y-axis. So there you're going to have pi. You're going to go from 0 to 8. And then it's outer radius minus inner radius squared. So here, since we're rotating around this one, it's going to be outer radius, 2 squared, minus inner radius squared. So you're going to have to solve that for the other variable. So outer radius squared minus inner radius squared. Again, solve this to get x equals, and that's what will go in there. Part B, we're now to the x-axis rotation. So that would be pi. We'd go from 0 to 2, and that would just be quantity squared here. What's touching the top of the rectangle minus what's touching the bottom of the rectangle. So that'll just go in there, and that'll be with respect to x. Part C. Part C again was around here. We're rotating around this axis y equals 8. So we are still going to be with respect to x. Now this is going to be a little trickier. We are going to have pi 0 to 2. What we need in here, outer radius squared minus inner radius squared. So again, we're rotating around here. What we're rotating around the farthest is what's touching this part, the bottom of this rectangle, and that's consistent all the way across. So that'll be your outer radius. Now what you need in here is a little formula that will give you the height of the rectangle as you work your way through there. So this will kind of be like one of the last parts of the odd problem we just did. You're going to need a little formula in here. Again, when you put in a 0, you will be 8 units away from the axis of rotation. And when you put in a 2, you will be 0 units away from the axis of rotation. Part D, where was that? Rotating around this line. So again, we're still going to be here perpendicular to the y-axis. So that'll be pi 0 to 8. And we are touching our axis of rotation. So we're just going to need something in there, quantity squared. This, what you put in here, again, will give us the height of that representative rectangle. So I hope these little hints give you a push in the right direction. Some of these problems can get a little tricky. If you're having any trouble, send me an email, and I'll try to help the best I can.